Hello everyone, welcome again. So today's lesson will be on the chemical earth. In particular, our study for today will be on a first-hand investigation, and it will be the decomposition of a carbonate. And in this picture here, you've got copper carbonate. You're heating it. The copper, I know it's copper because of that very greenish blue color that we see there. Okay, so we're going to look at decomposition of carbonate through heat. So our aim is to determine the products of thermal decomposition reactions, and in particular for carbonate decomposition reactions. Okay, so what do we need? Well, we need 5 grams of calcium carbonate. So we're not going to use copper carbonate like in that picture. We're going to use this whitish calcium carbonate in the picture. Bunsen burner, obviously, for the heat part of it. Test tube, rubber stopper, and optionally we could use Limewater. We don't need this, but it's nice to have for the results part. We also need a match. You can interchange these two, whichever one. If you have a matches on hand, that's good. If you have Limewater on hand, that's good also. So either one will be fine. So we need a methodology. So we place 5 grams of calcium carbonate in the test tube, like this picture. I'm not sure if that's actually 5 grams, but that's what we're essentially doing. Then we seal the test tube with rubber stoppers, okay, so like that. And then like in the first picture, we heat the contents of the test tube over the Bunsen burner for about 5 minutes. Okay, so we're heating the test tube. And then what we do is we allow it to cool. And this is important because if there's a gas produced, we want it to cool down so that it doesn't just fly away straight away before we can analyze what it is when we open the test tube, that is. So we want to try and keep the test tube cool, or at least cool it down so that the gases don't escape too quickly before we can get a sample and analyze. Remove the stopper and place the lit match inside. So that's our next step. And if the flame goes out, as in this picture, then CO2 is present. So that's like that burning splint test for oxygen. It's just the opposite of that. A lit match will get put out by the carbon dioxide. And that makes sense, right? Because you see carbon dioxide fire extinguishers. If there's carbon dioxide present, it will hopefully put out this flame. Alternatively, if the gas can be siphoned off somehow, so if we can maybe grab a sample through a syringe or use a sidearm test tube, we can pump that gas through Limewater, and that will actually tell us straight away if the CO2 is present. So as you see here from left to right, you've got clear Limewater, which is very nice. It's almost like liquid, like clear water, sorry. It is a liquid, obviously. Now, as you continue to pump CO2 in, it gets cloudier in the middle. And there's a little bit of carbon dioxide in there. And then as you continue to pump carbon dioxide, it gets whiter and whiter. If the Limewater goes from clear to milky white, then you know you've got carbon dioxide available, or carbon dioxide in that gas. So the results, what you should see. So CO2 should be detected by either the lit match or the Limewater. So in this case, the lit match will go out. In the Limewater case, the Limewater will turn from clear to cloudy. And we'll talk about, in the question segment, we'll be talking about what the reactions are actually happening in this process. But for now, we just need to know that if it goes from clear to cloudy, we've got carbon dioxide available. So that concludes today's lesson on first-hand investigation. This is very simple, practical. All you're doing is heating a sample and then extracting another sample from that. We're trying to see what the products of the reaction will be. So we'll move on to the question segment now, and hopefully you'll be able to answer these questions and expand your knowledge on this very simple first-hand investigation.